Now onto a subsection of geometric series. So last class we looked at what geometric series were. Now we are looking at infinite series. Now infinite series only exists when that common ratio that you have, the r value, is between -1 and 1, or it is less than the absolute value of 1. This would make the series convergent, which means it will sum up to a certain value, a finite value. While if the common ratio is not between -1 and 1, meaning it's either more than 1 or less than -1, then it's going to be divergent, meaning it's going to sum to infinity, meaning if you keep on adding the terms, it's going to go up to infinity. An example is this. Suppose we had the sequence 2, 1, a half, 1/4, 1/8, and so on. As you can see, the common ratio is 0.5. And that is between -1 and 1, or you can say the absolute value is less than 1. And if that's the case, then what happens is it will add up and it will end at a certain finite value. Meaning, if you keep on adding values of this series, it will never be more than 4. Meaning, it will, if you add it an infinite amount, it will convert to the value 4. Okay? We can make this more general, where we are adding a plus ar square and so on. And we know that the sum of n elements is a 1 minus r power n over 1 minus r. Okay? And if r is between -1 and 1, as n approaches infinity, Rn approaches 0. What do I mean by that? So imagine our r was less than 1. Suppose it was a half. Let's look at two examples, when the r is a half and when r is 2. And let's try to increase the value of n. So if you have a half power 1, it's just a half. Half power 2 is 1/4. Half power 3 is 1/8. And then 1/16. And then 1/32. And it goes on. This is getting smaller and smaller and smaller. And it's basically becoming closer and closer to 0. Right? As you go on, as n becomes very large, you're going to have a number like 1/2048, which is extremely small. While if you look at any value that's more than 1, let's say 2 for example, 2 power 1 is 2, 2 power 2 is 4, then we go on to 8, 16, 32, and this is getting larger and larger. So the r power n keeps on getting larger and larger, and it will go up to infinity, right? So because when r is between -1 and 1, your r power n approaches 0, what happens is we can write the sum to infinity as a times 1 minus 0, because n we have made it to be infinity. And this right here will just become a over 1 minus r as your sum to infinity. Then a few examples. The first 4 terms of a geometric progression are 5, 4, 3.2, and 2.56. What is the common ratio? So for that, remember, the first term is always a, the second term is a times r. So if a is 5, then 5 times r equals 4. And if we divide by 5 both sides, we get that r equals 0.8. And write down the sum to infinity. Now, why does the sum to infinity exist in this? Because 0.8 is between -1 and 1. Okay? And then the formula for sum to infinity is just sum to infinity equals a over 1 minus r, where a is 5, and then r is 0.8, so 1 minus 0.8, we get 5 over 0.2, which is just going to be 25. That means if you add an infinite amount of numbers in this series, if you add them all up, you will get 25 at the end. Next, a geometric progression has a common ratio of -2/3, so this is your r, and the sum of the first 3 terms is 63. Find the first term of the progression. So we know that r is -2/3, and we know that s3 is 63. S3, which is also written as a bracket 1 minus r power n over 1 minus r, where r is -2/3, n is 3, first 3 terms, and obviously this will be equal to 63. So we can write this down again, a 1 minus -2/3 power 3 over 1 minus -2/3. And that's just going to be a 1 plus 8/27 over 5/3. Because -2/3 power 3 is -8/27. Then remember, negative and negative becomes positive, so we are adding that 8/27 here. And here even we add the 2/3 to 1 and we get 5/3. This will then give us 35/27a over 5/3. What we can do is multiply by 3/5 multiply by 3 over 5 up and down. This cancels out, so the denominator becomes 1. The numerator 27 by 3, this becomes 1 and this becomes 9 if you simplify. And this becomes 1, this becomes 7. So at the end we have 7 over 9a equals to 63. And then multiply by 9 over 7, multiply by 9 over 7. We will get that a is equal to 81. Then we want to find the sum to infinity, for which the formula is just s infinity equals to a over 1 minus r. So we're going to do 81 over 1 minus negative 2 over 3, which is going to be 81 over 5 over 3. 81 divided by 5 over 3, which is just 48.6. Therefore, 48.6 is our sum to infinity, and our first term of the progression is 81. Lastly, something combining arithmetic and geometric series. It says the first, second, and third terms of an arithmetic series are x, y, and x squared. That means, remember arithmetic series, you have your first term is a, second term is a plus d, and third term is a plus 2d. And for geometric, we have that the first term is a, second term is ar, third term is ar squared. For arithmetic, the first term is x, the second term is y, and the third term is x squared. For geometric, the first term is x, second term is x squared, and third term is y. So here we want to find the value of x and we want to find the value of y. From this right here, we can nail down the value of r, because a times r is x squared, where a is just x. Therefore, x times r equals x squared. Therefore, r is equal to x, because x times x equals x squared. And if r equals to x, then here we're also going to multiply by x as well. And if you multiply x squared by x, we get y. That means y equals to x cubed. On the other hand, we can use the difference in this case, where a plus d minus a is equal to d. That means you have to add d here. So x plus d equals y, therefore d equals y minus x. And also here, plus d. Therefore y plus d equals x squared, and so d equals x squared minus y. Thus, y minus x is equal to x squared minus y. And if you rewrite this, you will get 2y equals to x squared plus x. Then what we can do is we have two equations right here, and we can simultaneously solve them. So 2x cubed equals to x squared plus x. We can rewrite this as 2x cubed minus x squared minus x equals 0. And if you want to solve this, this is a cubic equation which you haven't learned how to solve yet. So what we can do here is we can just factorize. X, 2x squared minus x minus 1 equals 0. And we can solve these two, equating them both to 0. X equals to 0, or 2x squared minus x minus 1 equals to 0. This one is going to give you two solutions, which are x equals to 1 and x equals to negative a half. We know that x is less than 0, and therefore x will be negative a half. Because x is negative a half and y equals to x cubed, y will just be negative a half cubed. So y will be negative a half cubed, which is just negative 1 over 8. From a, we got these informations. So x is negative a half, y is negative 1 over 8, r is x, a is x, and d is y minus x. This is all the information we will need to solve b and c. So for b, we want to find the sum to infinity of the geometric series. And sum to infinity is equal to a over 1 minus r, where a is just the value of x, so a is negative a half, so negative 1 over 2, over 1 minus r. R is also the value of x, so 1 minus negative a half. This will give us negative a half over 3 over 2, which is just going to give you negative 1 over 3. So that's going to be the sum to infinity of the geometric series. Now for the sum of the first 20 terms, remember that Sn equals to n over 2 a plus l, where l is the last term. But if we don't have the last term, we can rewrite this as a plus n minus 1 times d. And therefore we will have that Sn equals to n over 2 times a plus n minus 1 times d. Rewriting this for the fact when n is equal to 20, we will get S20 equals to 20 over 2 times 2a plus 19d. That will become 10, 2 times a, where a is just x, so 2 times negative a half, plus 19 times d, which is just y minus x, which is negative 1 over 8 minus negative a half, which is just negative 1 over 8 plus a half, which is just going to be 3 over 8. So plus 19 times 3 over 8, and that is going to give you 61.25. So that is going to be the sum of the first 20 terms. This is going to be the sum to infinity of the geometric series. This is the value of x and this is the value of y.